Alright, we're going to deal with imaginary numbers. An imaginary number is I, and we let that be the square root of -1, because there are no numbers that we can multiply times itself that gives us a negative number. So we created I. I is the square root of -1. So when we have a negative underneath the radical, as we do here, we factor it out and it becomes I. So in the example, we have -1 times 25, square root of -1, that's I, and square root of 25 is 5. So then we multiply those together, and we always put the real number part first, so 5I. So number 1, first thing I would do, take out the negative and make it I. Then take the square root of 4, which is 2. So we have 2I. Same type of thing for 81. We take out the negative as an I, and the square root of 81 we know is 9. Now 48 isn't a perfect square, so we need to break it down. 6 and 8, 2 and 3, 4 and 2, 2 and 2. Again, I scribble them out once I'm done with that. So I'm bringing out 1, 2, 2 2s. The 3 is still stuck inside, and the negative comes out as I. And then we multiply the 2 2s on the outside, just like what we've always been doing together. So the only difference is we have an I there as well because we had a negative number. Again, here in this one, it's going to be 4 times I times the square root of 27. This is 9 and 3, 3 and 3. I have a pair of 3's that I'm bringing out. So 4 times I times 3. 3 is left over. 4 times 3 is 12 times I times the square root of 3. Number 5, we got -3 times that, so it's -3I root 500. And we break this down. If we can notice, it's 5 times 100. 100 is 10 times 10. So I bring out a 10 times the 3, negative 3 is 3 there, times the I, 5 left over. So it's -30I root 5. Use complete sentences. Explain why Georgette's work is incorrect. She took the negative out of the radical here and just placed it outside, which is not right. We need to take the negative out and make it I. You need to poke out your I. So we should have an I times root 32. And then that's 16 and 2, so it's 4I root 2, not -4. So that's how we deal with the negative underneath. A complex number is a combination of real and imaginary numbers. Standard form of a complex number is A plus BI. And so we write the first one, or the real number first, and then the I term second. So here we can break down 50 into 10 and 5. That's 5 and 2. I have a pair of 5s that I'm bringing out. I have the 2 left over inside, and I have the negative coming out as an I. And I have 5 plus that because I don't have like terms, I can't add them together. Next one, square root of 64 is 8 minus, break down 63, 9 and 7, that's 3 and 3. So I bring out a 3 and an I, but I have a 7 left over. Again, they're not like terms, I can't combine them. Number 9. So we need to simplify the square root of negative 8. 8, break it down to 4 and 2. That's 2 and 2. So we have a pair of 2's with 1 2 left over. So it's 6 minus, bring out the 2, bring out the I, and leave the 2 inside. Then from here, split it up in two fractions. 6 over 2 minus 2i root 2 over 2. And then I can simplify more. 6 divided by 2 is 3. 2 divided by 2 cancels out, so I'm just left with I root 2. Multiply 2 plus root 7 by its conjugate. So its conjugate is the same thing, but a minus sign for the radical. 2 times 2 is 4. 2 times negative root 7 is negative 2 root 7. Root 7 times 2. And root 7 times root 7 is negative root 49. Two middle terms cancel out with 4 minus the square root of 49. Square root of 49 is 7. So it's 4 minus 7, which gives us a grand total of 3. So what do you remember about the type of answer you get when you multiply conjugates? The answer is an integer, the whole number. Complex conjugates are pairs of numbers of the form a plus bi and a minus bi. I is just a square root. This is the same thing as what we were doing before. So consider the complex number 5 plus i. The complex conjugate would be 5 minus i. Then we need to multiply it together. So 5 plus I times 5 minus I. 5 times 5 is 25. 5 times negative I is negative 5i. I times 5 is positive 5i. I times negative I is a negative I squared. Two middle terms cancel out. I'm left with 25 minus I squared. Now what is I squared? It says what is I really equivalent to? So I squared is equal to I times I, which is the square root of negative 1 times the square root of negative 1. Since they're both the same thing, we square it, and the 2 and the square root cancel out, so we're just left with negative 1. So I squared is negative 1. So it's 25 minus negative 1 turns into plus 1, so it's 26. So what is I squared equal to? It's equal to negative 1. Now let's multiply these by the conjugates. So 6 plus 2i and 6 minus 2i. We get 36, negative 12i, positive 12i, negative 4i squared. So those middle terms cancel out. I squared is negative 1, so it's negative 4 times negative 1. Multiply those together, we get 4. So 36 plus 4 is 40. 4 minus I and 4 plus I are conjugates. 4 times 4 is 16. 4 times I is 4i. Negative I times 4i is negative 4i. Negative I times I is a negative I squared. Middle terms cancel out. We're left with 16 minus I squared. I squared is negative 1. So 16 minus the negative 1, which is plus 1, so it's 17. Last one. Negative 5 minus 2i and negative 5 plus 2i. The sign on the 5 is still negative. The only thing we change is the one on the I term. So I'll multiply negative 5 times negative 5 is positive 25. Negative 5 times 2i is negative 10i. Negative 2i times negative 5 is a positive 10i. And negative 2i times 2i is a negative 4i squared. So the middle terms cancel out like they should. 24 times 25 minus 4i squared. I squared is negative 1. Negative 4 times negative 1 is a positive 4. And 25 plus 4 is 29. That's how you use complex numbers.